you're trying to do. And technology strategy discussions are part of how do you create value and how do you harvest it. So it's another look at it when it's a technology-based business. So we're going to see if we can get this working.
Strategy and the structure of the course that Joe Jacobson and I will be teaching, the structure of the course that my colleague Rebecca Henderson teaches in both MBA versions and for executives, has three pieces. We start with really asking, how can we create value? How can we match technologies and markets? We then start talking about, can we capture this value? So let's say we think that we've created economic value. Can we as the entrepreneur, as the venture capitalist, actually capture that value in the face of competition from many other people who might be trying to do the same thing? And the third piece we talk about is, do we have the organizational capabilities to really deliver this? So we might have a great technology, we might have a very good business plan with a very strong strategy, we might have raised money, but can we build an organization to deliver? It can be oftentimes very easy to write it all down on paper, but to actually do it can be extremely challenging. So in the course we cover these three pieces. What I'm going to do today is do a quick sort of whistle-stop tour of the first two, because I know that this is a course about the nuts and bolts of business plans. So this is actually about thinking about and writing down the business plan as opposed to actually raising the money and actually executing it. If you want to get into execution, there's a lot more that we should be talking about. Okay, so let me start off with this issue about how will we create value. Now, I have a lot of scientists who come into my office at MIT, a lot of engineers, who say to me, look, I have this wonderful new idea. So I think I'm going to be rich. And when I was at Oxford, which is where I used to teach before I came here, I had even more people who would come in and say, look at this very interesting molecule. This is a very elegant piece of chemistry. So they knew my background. They thought I'd be very impressed by this. And indeed I was, right? Very elegant, beautiful synthesis. Couldn't ask for more, right? Published in the best journals. And they would say to me, well, look, this is going to make me wealthy. And I would try and say to them, are you sure? How do we really know? Is this good idea always going to be a source of economic value? We know that in general, having a strong science base, doing a lot of basic research is good for economic growth. That science over here and economic growth over here are somehow correlated. But the real sort of causal mechanisms are very difficult to untangle. And to actually say that this particular idea is going to cause economic growth, is going to be of economic value, is quite difficult. Making that connection can be extremely hard. So the first thing that I just want to think about a little bit then is to try and address this question of whether indeed all scientific ideas have economic potential. But my a priori assumption might be that this should look like a straight line. Right? That there should be some nice relationship between the value of a scientific idea, and I use that concept a little bit loosely, right? But let's say an idea that has been well recognized by the other community of scientists and engineers as being a good idea, and its economic potential. Right? So not how much money was really made, but just the potential economic value in some loose sense, that ideas should somehow lie along this line. But in actual fact, we find quite a lot of them lie underneath the line. Clearly there are a few that lie above it, and we can talk about that as well, but the kind of interesting category, which is the category that many of my Oxford colleagues, fewer of my MIT colleagues fall into, is below the line. Why might that be? Why might it be that a good scientific idea just simply is not a potential source of economic value?
Yes. Its applications are limited.
Okay, so And what do you mean? So applications are limited.
Well, let's say a new molecule's been created that breaks some barrier that they've been trying to break. It might turn out that, it just doesn't have much use in the real world.
Right, yeah, so not very useful. We can't really think of anything that we're going to use this for. And clearly, that was the case, right, with, if you think back to sort of some of the Nobel Prizes, if you think about the carbon, the buckyballs, quite a big gap between that interesting, elegant molecule and finally today some uses. Now finally we have found some use for it, but at the time people had a hard time really conceptualizing applications and uses. So at least in a snapshot, in a short frame of time, ideas might be down here because they're not very useful. And with any other reason why? Yeah?
Not implementable.
Okay. And tell me what you mean. Give me an example.
Cost of building something or constructing some new technology just isn't worth it.
Okay, yeah, so we can't implement, and a good example of why we can't implement is because it's just prohibitively expensive. Any other reasons why we might not be able to implement, or any other reasons why we might not be able to make money? Okay. Yeah, so no product, which in a sense is saying we don't really know what to do with it, or even if we did, we can't really come up with a product because it might just be too expensive, even if we could have the imagination to think up something. Yeah, any other reasons? Yeah.
Social objections, like with cloning, for example.
Okay, yeah, that's a good example. So social constraints, let's call it. So there might be a series of regulatory constraints that prohibit us from doing something. There might be, as you say, a set of social constraints. I think a good example, and this may vary right from one region to another. So in Europe, it's quite difficult to do work related to genetically modified food technology. We can probably do that in the United States, and people have done that, but in the UK, for example, it's extremely difficult. So there are social constraints that mean that even though we've got a good idea, we really can't transform it into economic value. One other in a sense, this is a sort of variation on not useful, but in fact, this is more about market, but for a set of, again, social reasons that, and if you look back, actually, I think one of the most interesting things to think about in terms of whether technologies become of economic value, and all those films that look at the movies of the House of the Future, in the 50s and 60s and 70s, you see these incredible videos, normally of women in various sort of nice dresses with aprons on, and their hair all nicely done, kind of using these really cuckoo kitchen equipment. That are the kinds of images that people had of how technology was going to be used in the kitchen of the future, and kind of food in pods and all sorts of things. I don't know about you, but my kitchen certainly doesn't look like that. I don't go in it very often, but when I do, it certainly doesn't look like that. So there's no market, but in a broader sort of social sense. So we can think about uses. So I think that your point about applications is a little different, that we can think of some applications sometimes, but there may just not be kind of a social movement around it. It just may not be accepted because people just don't know quite how to use it. There's a famous UK inventor who invented this very strange bicycle, like a sort of recumbent bike that you could use. That was a great example of something that was actually quite efficient. It worked very well. It was a good application, but people just weren't willing to look quite so stupid on their way to work in the morning. Okay, so let me just come back to this one issue of can't implement, because I think that's really important. So we've said we can't implement because we can do it, but it's so expensive that nobody wants it. We could probably and importantly unbundle this into we can't implement because we just can't manufacture. We may not be able to scale up manufacturing. And that, I think, has been a problem and that's certainly a constraint and an issue in some of the biotech areas when we want to express a drug in milk of an animal. So when we want to do transgenic drug production, we can certainly scale up the number of goats and sheep that we have. That's not the problem. But to try and scale up the purification, trying to get those drugs out of these enormous quantities of milk actually turns out to be an extremely difficult problem. And so implementation is hard because they're of sort of process limitations. Yeah. Other implementation problems have to do with the fact that, for example, you might have an incredibly interesting technology, but that requires you to have a material that will withstand incredibly high temperatures. and that material just doesn't exist. So in a sense, your technology is dependent upon another, and there are these technical interdependencies. And there simply aren't the other pieces of the technological puzzle required to put it together to move it up to here. Let me just give you one more example that's a local example. It's not an MIT example, it's a Harvard example, and I apologize for that. But there's some work going on over in the medical school. I'm sure many of you have heard about it. Angiogenesis, blood vessel growth, going on in the laboratory of Judah Folkman. He has a really interesting paper about angiostatin, and I can't quite remember whether this inhibits or promotes blood vessel growth. But anyway, you can just give me some room to maneuver here. Now, he has published that article in Science. It's been widely cited and is now regarded as a very important seminal article on angiogenesis and an important identification of a crucial angiogenic factor. And yet, the company that actually licensed that technology has not done very well with it. And one of the reasons is that that was really not optimized as, the angiogenesis drug. It was simply the first angiogenesis, or one of the first angiogenesis factors that Folkman came up with. So from a scientific point of view, very important. From the point of view of economic potential, it simply wasn't optimized. And there are other better angiogenic and anti-angiogenic molecules that have subsequently been developed. So it forms the foundation of a lot of economic value. But as a direct, the direct connection between that particular molecule and economic value just doesn't exist. It just hasn't been optimized, it wasn't good enough. And that indeed wasn't why Folkman was trying to do this work. So nobody has a quarrel and says that makes the idea bad. It's simply that you can't establish that tight connection because it was very early stage basic research. Okay, so just a sense that we have to think about whether or not ideas have direct economic potential. So there's a whole other discussion about science in general driving economic growth, but in a direct sense there are lots of possible things that could intervene and stop that from happening. So let me ask the next question then. Let's say that we have an idea that has economic potential. Right? So we might think about this as just some sort of potential economic value embedded within it. We think that there's an application, we think that it's doable, we think society will accept it, we think that people will want to live their lives using this technology. Again, I might think that there's this nice linear relationship between the amount of economic value or the amount of economic potential in the idea, the amount of economic value created there for the taking, and how much economic value is actually captured by the startup. And let me say here, by the startup and the investors. Because the argument I'll always get immediately when I say, well, is it a straight line, is no, the venture capitalists make all the money. Right? So let me just put them together. Let's pretend for a moment that the entrepreneur and the venture capitalist is on the same side. We have to suspend disbelief for just a little while, right? And say, okay, let's assume that somebody has come up with an idea that we think has a lot of economic potential. It can create economic value. Will the people who try and take that to market really make the money? Will they lie on this straight line? Right? Which in a sense says the more sort of economic potential, the bigger the economic pie of value that's out there for the taking, the more you're likely to make. And does that look like a straight line?
Yeah. Are you talking in terms of revenue or market cap?
I'm not talking about either in a very precise sense, right? So I'm not going to do a sort of an algorithm for this. What I want to think about is, let's say that there is money to be made, right? So we might think about this as the sort of the area under the demand curve in some economic sense. I want to think about who's actually going to who's going to get that money, okay? And we might think about different metrics so we were getting precise about it, but we can think in general about whether or not the entrepreneur and the investors and other investors in the company in the stock market really actually make the money, or do they just go out of business? Does this look like a straight line, and who does sit on that straight line? Can you think of any kinds of companies or industries or products who really do seem to be able to make the money out of the idea that they have? Okay. we'll think about them in a minute. Let's put them on one side, because palm is one of my later examples. Okay. Any reason to think, give me an example of somebody who's below or above the line. Actually, as if we were very inexperienced. Now the question would be that maybe over time we'd be able to build up the experience, right? We'd really be able to build the company. So in the long run we are going to actually capture that value. I'm wondering though, let's say we can't and we actually just fail. Right? Who else might make the money, or why might we fail? Yeah? Okay, so competition. Yeah, so what we often see, right, is that somehow we end up not making as much, not actually being able to capture that pie for ourselves because of competition. So sometimes we lie down here because a competitor comes along. And the famous case that people often talk about, and a good example of a great new technology, is the CT scanner and EMI. So EMI, British company, has a lot of money because they have the rights to the Beatles records. They've been reinvesting that into all kinds of technologies, including medical technology. And they come up with the CT scanner, right, the sort of multidimensional X-ray machine that allows you to take slices of your body and look at it. And everybody agrees that this is an idea of scientific value, and the inventor of that, Hamschel, got the Nobel Prize. Good idea. Everybody agrees that physicians want this. So yes, there's a lot of economic potential. But eventually, EMI makes very little money. So EMI, with respect to the CT scanner, sit down here. And the question then is why? And what happened to them was that they went to market with this product, but they had very poor distribution channels. They had no relationships with doctors. When they did say to the doctors, look, we've got a great product, you must buy it from us, they actually had very poor aftermarket service. So the doctors were very fed up with them. And they wanted to buy the technology, and there were a huge backlog of orders because everybody thought this was incredibly interesting and exciting. But EMI were really not able to capture the value of the market because they basically pissed everybody off, all the physicians. And along comes GE, and GE are able to copy them. So GE's competition is able to copy them, and in a sense you might say, well, GE kind of lies above the line with respect to the CT scanner in particular. They didn't really create that economic potential, but they came along and stole part of that pie because EMI dropped the ball for a number of reasons. Right, so competitors can take away some of that economic value. Lots of people would argue like the Microsoft sits over here. Some people like me to draw Microsoft kind of over here. Sometimes I think that's a little bit unfair, but because they've taken a bunch of ideas that have really been created by other people, and in part because they've been able to create the industry standard. They've been able to sort of capture much more of the value in a sense than they really created. And that would be true too if you think of the VCR, right? If you think of those two types of VCR that you might have been able to work by way back when, the VHS and the Betamax. I don't know how many of you bought a Betamax or know somebody who did. Because I often tell people the only person I know who bought a Betamax was my grandmother. And I'm hoping it becomes a museum piece at some point. But you can imagine, right, that they had a very similar technology. And people argue about the specifics of the sort of fine-tuning of the attributes of the product. It's pretty similar. And yet, basically, Betamax kind of was down here, and VHS is up here. Right? If in a sense you might imagine, right, if we think about value created, they should probably capture about 50-50 of the market. What actually happened is that over time the sales diverged and Betamax basically collapsed, so they really didn't actually capture any value. And VHS captured the whole market. And so in industries where there's an industry standard, you can often capture more of the value in a sense than you really sometimes create. Other reasons for being down here then have to do with standards. So if you lose a standards battle, you can end up below the line. You might also choose to be down there as part of your strategy, and it's worth saying that a company like Philips, with the CDs, is down there. They could have made, or you might argue, like they could have made a huge amount of money on every single CD that's sold. Instead, they basically license the technology, and they make a royalty of, a penny on every CD, whatever it might be, a cent or something. And so they actually chose to be below the line, but in a sense their argument was, if we do that, then we're going to have a small piece of a very big pie, instead of a big piece of a smaller pie, or a pie that might even not take off. So it could be very specifically to do with a licensing strategy or something else. The other famous company under the line, right, is Xerox. So we know that Xerox come up with all these ideas in their Palo Alto Research Center. They come up with the GUI interface, they come up with the mouse, they basically came up with Adobe, and yet they dropped the ball. And so the other reason for being down here, especially for large companies, is simply just sort of managerial oversight, which is a very polite way of saying they were stupid. And it's actually, I think it's a lot more complicated than that. If you talk to the people who founded Park and some of the early directors, they blame the accounting people. The accountants blame the technologists for not explaining the technology properly to them. So everybody's blaming everybody else. It's a classic problem of large companies to have good ideas and then simply not be able to capture their value. So we might put Xerox Park out here. But the point here is that your technology strategy has to address both these graphs. So the way I think about technology strategy is that you have to think first about value creation. You have to think about the question, does this technology or scientific idea create something of value for customers? Right? Is this something valuable? Which is my first graph. And then secondly, you have to think about value capture. We think we can create economic value. Can we capture that value in the face of competition? So given that there's lots of competition, can we really create that value? And so your technology strategy, or another way of putting it, your business model, which I think embeds, technology strategy is kind of embedded within your business model and makes up a large chunk of it. The way I would define it, other people would differ, right? Your business model is basically something very simple, right? How do you plan to make money? It's the way you decide to transform your scientific idea into economic value and into economic value that you capture. So that's the business model, a very trendy word at the moment, one that people like to throw around a lot. I think especially in the aftermath right of the internet, where people discovered that there really wasn't a business model. There actually was not a way by which these companies planned to make money, nor was there a way of transforming the idea, if there was one, into economic value. But that's just a general kind of picture of what the business model really is. And another way that I like to think about it is basically the business model being a way of mapping from a set of sort of technological attributes or scientific attributes to a set of economic ones. So mapping from a set of technological things that you can do. I can make this molecule, I can write this software, right? I can program this chip. This new material will withstand this amount of heat. These are all technological characteristics. But I somehow need to map them to a set of economic characteristics. I'm going to make this much money. I'm going to make this many profits. I'm going to have this much market cap. And so I think of the business model and the sort of, especially the technology strategy piece of it, as a sort of a mapping, right, from this sort of technical domain to the economic domain. So in a sense, right, the business model is just the kind of the matrix transformation that you need to do on one to get to the other, to put it in a very sort of MIT kind of sense of the world. And sadly, if I knew the algorithms by which that mapping happened, I would, first I'd probably keep them to myself. I might be able to make myself very rich. And the problem with this, right, is that this is very difficult to do. It's hard to do well. Why is that? Well, it's because whilst these might be stable, and let's assume the technical inputs stay the same, which I'm not sure they do for all the reasons we talked about, that there's inherent uncertainty on the left-hand side. On the right-hand side, mapping to these economic outputs, what's mediating that in the middle are markets and people who have strange behavior that's often unpredictable, competitors whose behavior is often unpredictable, who are doing secret things in their laboratories that we don't know about. And that this is just an underdetermined problem. There are lots of ways in which we could affect a mapping. Some, in the long run, may turn out to be better than others. We don't always know which. And so, in a sense, the business model and the business plan is all about thinking about that transformation. And I was at a talk the other night by Lita Nelson, who's the head of the Technology Licensing Office here at MIT. And if there's anybody who's probably seen more people go through this transformation process, in the MIT context, it's probably Lita. And this is obviously also something that investors and venture capitalists do and think about all the time. She made a good point, I think, which is that the business plan is the place where you write down your thoughts about this, but it's much more important to spend time thinking about this than kind of wordsmithing the writing. You probably want to spend, 80% of the time thinking about this transformation and 20% of the time writing it down and kind of making it clear. But it's the thinking about it and the kind of hard conceptual logical thinking behind the business model that's really the key, and not how beautiful the business plan is and how many graphics you've got in it and so on and so forth. And I think that sometimes there's a problem that people spend more time trying to make the business plan look nice and not enough time really thinking hard about that transforming function. So let me just talk a little bit about these two pieces of this, right? Because this business model has a number of elements, and I've said that two of the elements, one's going to be about can we create value, and the other one is going to be can we capture it. There's then going to be a whole series of things about the revenue stream and the costs of financial structures and the organizational structures, which I won't talk about at all. All right. So let's talk about value creation then. And the way I would try, and what I'm trying to do here is just give some logical framework for thinking about things. There are clearly lots of ways of thinking about this, but this is just the one that I think is helpful. Value creation basically asks, right, what's your value proposition? What do you propose are the attributes that are going to be of economic value? And then you have to ask, right, well, who cares? Who cares about this value proposition? Who are the group of customers for whom this value proposition is relevant? And obviously we'll talk a little bit more, we'll talk in much more detail afterwards. About the specifics of the market piece. I'm going to talk less about that. But the first thing I want to say is that these valuable attributes belong to products and not technologies. And they aren't couched in terms of just these technological attributes that, we can make the molecule and so forth. They're attributes that sound more like faster, more efficient, cheaper. So they have more of an economic flavor to them. And they basically have to be wrapped up in the product or solution or service and not really just in the technology itself. And people basically don't buy technology. People buy products or services or solutions to problems. So you have to map from a technology to a product. As I say, I'm using that word very generically, right? Because clearly you don't always have an object, right? It can be a service, it can be a database or whatever it might be, but you have to get from technology to sort of the product, the way in which you deliver this set of attributes. And that has to be something that people want. So again, all very well for these people to come into my office and say, hey, I have this technology, they might tell me it'll do everything cheaper and faster and better. But the question remains, is there a market? So a lot of value creation is about being very careful and thinking very clearly about the match between technologies on the one hand and markets on another. And the value proposition is about what that technology is going to deliver as a product or solution to people. And then you have to ask the question, what's the market, right? To whom are we going to provide those attributes? Who cares? And as I said, there are lots of ways of doing that. There's typically not one transformation that you can do. I looked at the virtual link plan, and it's harder for me to tell whether or not there are lots of possible ways in which you could use it. And the flavour of the plan sounded like you were very clear about which products you could make. And there's obviously a behind-the-scenes set of conversations about how you can embody that in the technology in a set of products. Sometimes that's easier than others, I think. And so the fact that you can use this technology in different ways means that you have a kind of a complicated problem that you just have to think through in a logical way. And you have to think about it in the context of the market on the one hand and the technology on the other. So let me say a few things about the market, and I'll just leave the market at that. But the kinds of questions you might want to ask about the market are, well, which customers are most willing to pay? Where is this the most significant improvement, right? So who are the people who would care the most about you being able to provide this product that can do something faster? Like, who values speed the most? So you want to think about the customers and the markets for whom this is really important, and map that to the attributes that you actually really can provide. And you also have to ask the question, who is most willing to pay? Right? So it might be that you have a fantastic vaccine for malaria, but sadly we know that people, it's not about willingness to pay, it's just an economic expression. People are not able to pay. So your technology can provide a product, a malaria vaccine, which has some remarkable attributes. You can't map that to the market because there simply isn't an ability to pay. And that then leads back into the reasons why many of the reasons why we don't have solutions to some of these sorts of problems. This is why you wait for somebody to create an artificial market, for Bill Gates to come along and basically say, if you solve this problem, then we'll pay. What the Gates Foundation is doing is just creating an artificial market, people who do have willingness to pay. So that's all I really want to say about the market side of things, because I want to leave there's much more to say about that. But let's talk about the technology side. Your technology could be used in lots of different ways. And you might want to think about which ways in which it's best to use it. Which product should you bundle it up into? And I wanted to just give a local example. It's the example of a local startup from the Media Lab, E-Ink, which was co-founded by Joe Jacobson, who I've already mentioned I'm going to be teaching with. E-Ink has a very interesting technology that I know I'm not going to describe at all well. But imagine sort of little balls that are kind of molecules that are black on one side and white on another, and when you put them near an electric field, you can kind of flip them around. So you can imagine you can use that electronic ink to make signs and to make words. There are multiple things that you could do with that technology. But let me tell you three of them that E-Ink had in mind. They thought, well, we could use this for signs, right? We could use this for enormous signs in stores where they want to change the sign, mark down 20%, and then the next day mark down 50%. Or when an interested buyer comes along, the markdown gets less because they think, oh, you're probably going to buy it even if it's only 20% markdown, right? So just this notion that you have some flexibility in signs was one possibility. And I'm using these are not exactly right, so I'm using a lot of kind of poetic justice in my descriptions here. Second possibility you might imagine is sort of e-newspapers. So you might be able to use this to create a newspaper every day. So there's another possible application, a bit more complicated, right? Something that's going to require any individual to have all the other kind of technology and the printer, for want of a better word, that they might need to actually do this. And finally, let's think about e-books. So these would be something where you turn a page and the writing changes, right? You've got page 1 and you turn over and it's Harry Potter page 2. So a more complex technology. But these are three different possibilities. Now, those, I think, in a sense, sort of stack in terms of complexity. But that's not always the case. So there's another quite interesting MIT company, it's a much older company, Materials Technology Corporation, who had some really interesting ceramic technology. And they had the ability to make very specialized kind of ceramic materials that had a very fine microstructure. I'm sure if they were around today, it would be a fine nanostructure of some kind, and they'd be a nanotechnology company. But they really weren't quite sure how to use it. They could use it in the nozzles for steel making, they could use it in certain engine parts. All these were sort of equally the same in terms of complexity. And so they had a very hard problem to decide which one of these things to do. Let me just give you a sense of how I would go about thinking through that problem. In the E-Ink case, I think it's quite clear that you probably want to think about a path from simple to more complex to more complex. So you might want to think about your products as going from something that's relatively simple and kind of knowable to something that's gradually more complex as you get more sophisticated with the technology. So you might map out a product portfolio that goes from a straightforward product to things that are more and more complex as you learn about the technology. So you want to ask the question, are the applications equally technically doable? This is why these companies need technical people. It's not good to just have the technologists sort of in a room having handed over the technology and leave it all to business people and to marketing folks. You need to be engaged in a conversation about what's doable and what's not. So you want to think about what's doable. You want to think about which are more complex, which is subject to much more uncertainty, which are the projects for which there are simply pieces that we don't understand. So we're going to have to do some more basic science before we can even figure out how this product works. So I would want to ask a whole series of questions when I think about different possible applications. If I'm in a situation like the Materials Technology Corporation where I may have partners to work with, so Materials Technology partnered up with various people in these different products. And so one strategy is not only to choose these things, but to then form a set of partnerships. So in the steel-making case, there were always problems. This thing never worked, but they couldn't figure out whether it was a problem with their technology or with the steel processing technology. Because the steel processing technology was sufficiently complicated that they couldn't define all the temperature and all the boundary conditions, and so they couldn't really understand whether it was their technology going wrong or their partners, whether the problem lay with their partner. And so clearly a product or a solution which is this highly coupled solution is just not a very good way of starting, because you have huge amounts of uncertainty in that problem. So if you can find something more simple, that seems more sensible. Second thing is applications on the path to progress. So you might have this grand vision out here of an electronic book, but it may be sensible both in terms of learning about the technology and building revenue streams as you go along, to think about a more simple set of products, but where each product gives you some learning that you can use to develop the next generation of products. So you don't want something that takes you off on a tangent. It's very important that these have some sort of logic where you're building technological progress. And I think there's clearly the same on the market side, that there are a whole series of similar kinds of questions. But with the technology, those would be things I would really want to think about when I'm trying to match technologies and markets. Okay. Let me just now turn to value capture. So let's assume that we've thought about a set of products, and we've thought about a sort of a natural progression. We've thought about the technological steps that we need, and we've come up with products that we think we have a relatively, maybe not as straightforward, but we have some idea of the technical steps, the kinds of uncertainty that are associated with developing those products. And we've got a value proposition that we think that the market will appreciate. Okay. So can we protect our value proposition? Can we protect our competitive advantage? Our advantage is the fact that we can deliver this value proposition. The concern that I would always have is, can you protect that? Are you going to be the only ones who can do it? Let's say you can create that value, you can create that signage technology, you can make that steel nozzle out of ceramic material. Can you actually capture the value? Can you make the money? And the other question you need to ask, I think, is really how can you deliver this to customers? And that I'll get to at the end. But a key question in value capture is going to be protecting your value proposition. And so what I would think about is a sort of protective layer that you wrap around your value proposition, that you somehow wrap around your customers to try and stop them from working with other people, that you wrap around your product or your solution, and that you try and wrap around your technology. So what you really want to do is think about how to protect these things from your competitors. And particularly in startups, and particularly in technology-oriented, technology science-based startups, I think there are probably 4 key ideas in this sort of protective wrapping that you want to put around the technology and the product. Okay. And this is why I said I'm not just going to talk about technology, and I'm going to allude to some of these other pillars. Because clearly the most significant is typically intellectual property. And I say that especially here, Right? Because really, many of the ideas and the companies that you see coming out of MIT, that they core have some strong intellectual property. Intellectual property is not enough, right? You need, intellectual property may protect the technology, but that technology has to be a source of value for somebody. It has to have the value proposition. You have to think about the products. You have to be able, they have to be technically doable. People have to want to buy them, etc., etc. But at the core, if you solve those problems and then you go to market, and you don't have a good way of protecting your ideas, then somebody will turn around and say, hey, that looks good. I think we'll do that too. And GE did that exactly with EMI. So EMI had not only made all their customers rather fed up, but for various reasons to do with the intricacies of intellectual property law, it was relatively straightforward for them to invent around the patents that EMI had. And so they really weren't able to protect their ideas. So I put intellectual property at the beginning, controlling the knowledge underlying your technology or your innovation. Has some problems, right? It's expensive. It also has the problem of telling everybody what you can do. Now at MIT, that's often not an issue because you often want to tell them anyway because people here work in labs and they want to publish. And that's how MIT works. There's a lot by publishing and publishing a thesis, publishing papers and so on. So you try and publish and have intellectual property hand in hand. And that can work quite well. But the fact remains that in return for being given some ability to exclude others from your idea, you have to tell everybody what you know. And so there is a trade-off there. So the other alternative, or another alternative, is secrecy. You can keep your idea to yourself. This works quite well with process technology. So when you have a new process that you can use to solve a problem of some kind or make some product in a different way, right? If I see the product, I don't know how you've made it, right? It's unobservable. Your process is just not observable to me. So sometimes people use secrecy for a process. There's perhaps another thing that I should put in here, right, which is basically the idea that something is sort of tacit or in human hands, or it's kind of, in the sense that there may be particular skills that somebody has that are simply very difficult to imitate. So the other way in which you can protect your idea is to have that idea just simply be something that no one else in the world knows exactly how to do. And in medical devices and things, in the early stages, you often find that there are only a few surgeons who can really figure out how exactly to do something. It's a bit problematic, right? Because if you want to have this be a well-used medical device, you're going to ultimately have to train lots of people, other people, to do it. But having this sort of tacit human skill can sometimes be valuable, especially in the early stages of a company. It can also be valuable in consulting, right? If you think about a consulting company, the whole basis of a consulting company is the kind of the human skills that people have. The reason why they're, and brand, I think, is probably the other piece of it, right? I mean, you can probably have an equal number of smart people that McKinsey has, and you can probably have all the frameworks that McKinsey has, but they have a brand and a reputation. So these things could go hand in hand. But the sort of tacit human skill, if you have the group of the only people in the world who can really figure out how to manipulate a particular material in a certain way, then that can be very valuable, certainly for a short period of time. Speed, another thing that you can do. You can basically keep moving beyond your current competition. You understand the technology better, you can simply move ahead faster. And in that way, you don't protect necessarily the key idea, but you protect the business because you keep on moving. And finally, there's something to do with customers, right? We shouldn't just think about protecting the idea and stopping other people using the idea. We might want to think about protecting our customers. And what that really means is locking them in, making it such that it's expensive for them to change from your technology system to somebody else's. Customers don't like that typically, right? None of us like being subject to it. Banking is a good example, right? It's very expensive for me to change my bank account. There's so much sort of stuff I have to go through. I'm somewhat kind of averse and irritated by that whole thing, but the fact remains that my switching costs are quite high. Well, I think having a patent portfolio can be seen in particular kinds of businesses as something very strong. So if you think about the biotech industry, for example, having intellectual property is extremely important. If you think about why Amgen makes all its money from EPO, it's because of its intellectual property, and they spend a great deal of money fighting off TKT to make sure that they maintain their patent rights. So intellectual property is important, especially in technology-oriented businesses where you might be able to copy something. But it's not the only thing. So I think if investors were to see an intellectual property portfolio and either a very well formulated way to leverage it, right, which is what the business model is sort of all about, what's the value proposition, which products, then that's something that looks very appealing. Sometimes people will see it incredibly about some very valuable intellectual property and say, fine, this may not be the team that can really figure out how to capture that value, but we'll find somebody else who is. Or put them together with somebody else with some complementary technology. But yes, I think in many cases it's important. Okay. So